Hello. Tonight I will be discussing the Volatility Framework and how to use volatility to analyze memory images of Windows and Linux. My name is Wyatt Tauber. I'm a third-year student at RIT. These are some of my interests. I travel quite a bit. I've presented at a few cybersecurity and technology conferences, and I enjoy volunteering for STEM education and advocacy causes. My goal is to make technology more secure and accessible for everyone. Tonight I'm going to start by going over some basics of memory forensics that I've picked up via classes, clubs, and competitions. I'm going to talk about how memory is structured, how to analyze it safely, and I'm also going to discuss a new version of volatility, Volatility 3, and how it differs between Volatility 2 and some new features introduced in Volatility 3. I'm also going to talk about how to analyze memory with volatility, how to create a dump and run some of the plugins that come with it, and I'm going to wrap up with identifying injected code in Windows. I have two goals for today. What sensitive information is accessible via the memory, and how can I retrieve information in a forensically sound way? So basically, how can you see what is in your memory and access it, and how can you exfiltrate it in a forensically sound way, or without overwriting or corrupting it? So let's move into the first topic. Memory forensics. How memory is stored and accessed. Specifically, how can we use it with volatility? Volatile memory, or RAM, isn't too difficult to define. It's memory that requires power. So if you turn off the PC, usually that memory is gone. It's used to store all running applications, which is why we keep needing more and more of it, so it's overwritten a lot. It's a snapshot of any applications that you have open, anything running in the background, network activities, users and users' activities, open files, open ports, IP addresses, a lot of different things. So how do we analyze this memory? Well, we can set up a forensic environment. This type of environment gives you all the tools you need and takes a few safety precautions to keep you from screwing up. OSs such as SANS SIFT, which was created by the SANS Institute and Rob Lee, and Remnux, which is created by Lenny Zeltser, are two virtual environments built for forensics, although Remnux is a bit more for the malware forensics and reverse engineering side of things. It's also helpful to have specific tools for memory forensics. Memory imaging applications are helpful to obtain the memory we just discussed, and a write blocker so that you don't make any changes to the file system while you're trying to obtain the memory, because file systems might be important later on too. This is how a memory analysis application, such as Volatility, sees the memory image you captured. Memory isn't stored sequentially anymore, so applications in the operating system need a way to see which segments of memory are connected, so it can be unified in the processing. Then the application uses the memory segments it's connected to obtain data called objects. Objects provide an easy reference to where specific types of data are stored in the memory and what the application can follow to get to them. Templates just contain the structure about an object. Symbol tables are tables that the application reads to get all this information. It's usually required for applications such as Volatility to run, and they're highly specific to the operating system they came from. Now that you know a bit more about memory and how it's processed, we can move on to discussing Volatility 3. It's currently in its first public beta. It was released at OSDFCon on October 16, 2019. The Volatility Framework is one of the most popular memory analysis frameworks. It's written in Python. It supports Linux, Windows, and Mac, and it's open source. Two important parts of Volatility I'll cover here and later in the demo are the plugins, which are used to perform different types of analyses on memory images, such as reading the process list or browser history. Users can also write their own plugins to extend the functionality of Volatility, and AutoMagic, which uses pre-existing modules as well as configuration from the memory image to make changes to the context that Volatility will use to analyze the file. In other words, it can figure out the elements that, if a user hasn't provided them, it can self-populate them independently. Volatility 2 was created in 2006, originally as FATKit. Since then, there have been several major developments. In 2007, it was renamed to Volatility. 2009, they added malware detection, or malfind. 2011 added support for more Windows versions since Windows XP, such as Windows Vista 7, 8, and 10. In 2012, they added Linux support. And in 2013, Mac support was added along with ARM support, and the Volatility Developer Program branched out into what is now Google's Recall. Recall is a fork of the Volatility project maintained by Google. Python 2 won't be maintained past 2020. The Volatility Foundation plans to release the official version of Volatility 3 in August 2020, and after that, Volatility 2 will only receive plugin and operating system support updates. Volatility 2 development and support will end in August 2021. Only development of Volatility 3 will happen after that. One of the most important things about Volatility 2 is that it requires a system profile. Profiles are zip files with information on the kernel's data structure and debugging symbols. Volatility 2 needs these in order to understand the context of the operating system it's analyzing. Volatility maintains a list of downloadable Linux and Mac profiles, but these don't always work. Creating a profile on Linux can be inconsistent because they're so highly specific, but creating your own profile is always best. This can be done in the 3 steps I've outlined on the slide. You can create a kernel structure by building the contents of lib modules, and then create module.dwarf file by running dwarf dump, the application dwarf dump with the resulting module.o file from the previous step, and then zip the module.dwarf file and the system.map file and place them both in the Volatility Profiles folder for it to identify. A couple of big changes have happened between Volatility 2 and 3. The first one is that there are no more profiles. This is a big one. All you need to do is download 3 zip files from the Volatility Foundation's website to have the symbols you need for most operating systems. Second is in-memory code evaluation. Some forensic analysts are reverse engineers as well, and most can read basic assembly, but it's not usually their specialty, so automatic evaluation of encode found in memory to make it more understandable is very welcome. Finally, plugin naming has changed. There's now this 3-tiered naming system for plugins, the last of which is case sensitive. Previously, the plugins were just the name for Windows, and then other OSs got appended on the front if you wanted to run the Windows command on a different operating system. Now, you just specify the command you want to run with the OS you want to run it on. For example, Linux check modules has become linux.malfind.malfind. That 3rd tier is probably in case they want to add additional malware finding functionality later or allow better grouping by category. Most importantly though, the last command is always case sensitive. This chart illustrates the complexity changes in Volatility 3 very well. Per the developers, all code in Volatility 3 is new. Nothing was ported from Volatility 3, and everything was rebuilt from the ground up. Volatility 3 is highly automated. It uses detection of the operating system when possible. It uses data structure and disassembly analysis and kernel module analysis to figure out which operating system this memory image is coming from and how to properly analyze it. We'll be demonstrating this functionality later on. Now we can talk about memory analysis. So how do you create your own memory dumps and read information from them? Well, it's not too hard. There are a few applications that can do this for various platforms, and I've listed a few here. Memorize is a helpful utility for Windows and Mac made by Mandiant. It will create a memory dump of the entire range of system memory for the operating system, and it can be downloaded for free from the FireEye website. And there's Lime. Lime stands for the Linux Memory Extractor. It's a kernel module, so an extension to the Linux kernel. If you want to install this, you'll need root permission. But it can analyze memory from any Linux or Linux-based device, including Android. It's also forensically sound since it has a lot of options for where to send the memory other than the local system, and it runs very quietly. Here are some common commands you can use when running Volatility. I've picked out some that I use quite often. Windows Hive Scan scans for registry hives present in a Windows memory image. Malfind lists process memory ranges that potentially contain inject code. For Mac, check syscall checks if system commands have been hooked or replaced with other commands, which is common of malware. Check systemctl checks for unknown systemctl handlers. For Linux, the bash command recovers bash command history from memory, and importantly, it does this through the prompt directory rather than the bash history file itself. So even if the file is modified, deleted, or has anti-forensics used on it, it usually can be recovered. And elf, which lists all memory mapped elf files for all processes. There are several generic commands that work across all operating systems. Some of these are pslist, which lists the processes present in a Windows memory image, pstree, a plugin for listing a process in a tree based on their parent process ID, procmaps, which prints details of processes memory, including heaps, stacks, and shared libraries, procdump, which dumps a process's executable file, and netstat, which lists open and closed network connections and port statuses. Yara is an open source tool designed to help malware researchers identify and classify malware samples. It creates rules for malware families based on textual or binary patterns, and Volatility can use these rules to analyze a memory dump for malware. And now, it's demo time. I'm going to be using Volatility 3 to analyze a Windows memory image of a system that was infected with the Zeus malware from 2009. This sample was provided in the Malware Analyst Cookbook and is a pretty common image for volatility demonstrations. Okay, so to do this demo, I am in my Ubuntu 18.04 VM. We don't actually need a forensic environment for a demo, so I am going to start by installing Volatility. Volatility can be installed from its GitHub page. It is at github.com/volatilityfoundation. And you can see we have a couple of options here. Here's Volatility 3, which we are going to focus on, and down here is also Volatility 2. You can tell via the commit message or the commit logs that Volatility 3 has had a significant year of development. To download Volatility 3, we're going to click Releases and download the beta version. I am on Ubuntu, so I am going to download the tar.gz file. If you are on Windows, you will need to download the zip file. I'm going to save that. I am also going to download the symbol tables that are needed. Symbol tables are linked under here. They are Windows, Mac, and Linux. I'm going to save those as well. And those files are downloading. Now that the files are downloaded, we can extract the Volatility folder and place the Windows, Linux, and Mac zip files in Volatility symbols. Now let's open Volatility in the terminal just to see if it works. And we want to run vol. And I'm just going to run -h for help. Let's make this a bit bigger. It works. Now, it looks like we don't have a couple of prerequisites installed for things such as the Yara scan, which won't be a concern for just this demo. But these are all of the modules that we can run with Volatility. Now I'm going to get a memory sample. These memory samples can be found from the Volatility Foundation's normal Volatility repo. And the one I am going to get is the Malware Cookbook DVD, because it has the image that I will be analyzing. I'm going to save that. And wait for it to finish downloading. It is finished. So I'm not going to extract the entire DVD since it's rather large, but I'm going to go into folder 17-1, and here is our zeus.vmem file. So let's extract that. Extraction is completed successfully. Now we have our zeus.vmem, but it's zipped again, so extract once more. And now we have our Zeus.vmem file. This is the memory image that we are going to use with volatility to analyze. So let's open volatility once again. I still have it here in the terminal. And now let's run vol.py -f for file. And now it's up one level and in a different directory. So I'm going to navigate to that. Zeus.vmem. And then this is, I know that this is a Windows memory image, so I'm going to do windows.info. Start out. And now I will make this a bit bigger again. We can see that we've listed a bunch of information about the machine that this image was taken from. So we have things like the memory layers and the machine type, number of processors, the system time when it was imaged, the root directory, and other information. So let's run some other commands such as windows.pslist. And here we can see a list of the processes that were running when this machine was imaged. There are a bunch of other Windows commands that we can run, and if we just make a mistake, such as just saying just Windows, it will list them out here all for us. Now let's run windows.registry hivelist.hivelist. Here we have a list of the registry hives that were contained on the sample system. So this would be useful for a forensic analyst if they wanted to check if any of the registry hives or keys in them would have been modified. The last command that I want to run with volatility is windows.malfind. Oops. Well, this is still a beta, so we can expect some errors while they work out all of the bugs and correct them. So this isn't a big deal. We still got a bunch of output. The malfind command helps find hidden or injected code in user memory. So all of these listings that we have here are portions of the Zeus malware that have infected various binaries and other files in the system. There are quite a lot of them. Well, that's the end of this demo. I hope you enjoyed it, and maybe volatility will be useful for you sometime in the future. Thanks for watching.